All right. And with that, I'm excited to introduce our first presenter on the Networking EcoCast, and that is Rajiv Ozdag. He's a Vice President of Product Management for the Visibility Portfolio at Ixia. Are you there?
Yes, I am.
Excellent. Thanks so much for being on the Networking EcoCast. Take it away.
All right. Well, hello, everyone. My name is Rajiv Ozdag. I'm the Vice President of Product Management for Visibility within Ixia's Network Visibility Solutions. That's NVS. Ixia is traditionally known as a test company, but it has also entered the visibility space. And in 2012 and 2013, it made two acquisitions. First, it acquired a company called Anui, which was known for designing and delivering high-end network packet brokers. And we're going to go into that in a bit more detail. So they were well known for high-end, high-performance platforms, as well as they were very easy to operate because they had these awesome interface, graphical user interface that I'll show. Also, we acquired a company called NetOptics, which was the #1 tap and bypass switch vendor, and we'll spend a bit of time on that too. In 2016, we combined the technologies from these companies and added our secret sauce that comes from the test division and delivered our first 1U all-in-one platform, the Vision 1. And of course, with the advent of cloud in 2016, May of 2016, we announced our Cloud Lens platform, which provides visibility and therefore security for cloud. And we started with Amazon, and we just added multi-cloud support a couple of weeks ago. And so with multi-cloud support now, you can essentially monitor all your applications, all your workloads, all your data, regardless of the cloud service provider, Azure, Amazon, CenturyLink, IBM, a very long list. Now, I do want to mention that, I'll be using the words visibility and monitoring interchangeably. And really the #1 driver for visibility is eliminate blind spots for security. Now, providing security in a network is very challenging. We all know that. If you just look at the past, whether you can think of some of the breaches that happened with Yahoo, Target, Home Depot, and of course, most recently, Equifax, almost every enterprise, it's not a matter of when, it's a matter of when they'll be breached and the devastation that happens later on. What is the damage? So the goal really is to eliminate blind spots. Now, security is the #1 driver for visibility and monitoring, but there's other drivers too. Application performance monitoring, network performance monitoring, troubleshooting, being able to reduce the amount of time it takes to troubleshoot when something goes south. These are all drivers. But I would say, again, security is indeed #1. And because of that, there are a whole multitude of companies that operate in the security space. Here on the slide, you can see a number of these. I'm sure that there's a number of device vendors that I've still left out. The question is then, how do you connect all these devices to your network to provide security, to provide application performance monitoring or network performance monitoring? Well, if you look at your network, on the left, it can be a main data center. It can be a WAN environment, a campus, a branch. There's also virtualization and a cloud. And on the right, you have all your tools. And these tools might be used by different organizations. Some tools are shared among organizations. Some organizations bring their own tools. So the question then is, how do you get all that data from your production network to your tools? It's essentially very challenging. Now, you can use taps and span ports, and I'll go into that. But the issue is that there's just so much data in our network that there's not enough tool capacity, or it would be financially almost impossible to acquire all the tools so that you can send all that data to your tools. So something has to happen. And this is really where visibility comes into play, because you want essentially a fabric that sits here that provides end-to-end visibility, that identifies which data should go to which tool. For example, some tools only look at the packet header. Well, if it only looks at the packet header, why would you want to send all the packet information to the tool? You wouldn't, because it would just be wasting bandwidth. Some tools cannot do SSL decryption, and because most of the data nowadays is encrypted, well, how do you get the most out of your tool? You don't want to just throw away that tool and buy a new one, so maybe you want to have a platform that can do SSL decryption. There are various reasons, and I'm going to go into more detail, but essentially, this is where what we call a visibility fabric or a security fabric comes into play. It helps you access all that data and send it to the tools so that it makes it a cost-effective way to monitor and secure your network. Here's just a handful of devices, and again, even if you're not connecting hundreds of devices, any number of these, connecting them is going to be a challenge, and this is what we do essentially. We provide this fabric called Ixia visibility architecture. It consists of a number of products that constitutes this architecture and allows you to connect your devices. Now, step number one is to access data, and the way to access data is to use taps. Taps are very simple devices. If you think about a fiber connection, information is transmitted through a light. So we want to be able to copy that data to send it to our tools. A very simple fiber that you're seeing on the picture is it just has some mirrors in it, and it will just copy the data. So we'll copy the data from your network outside of the network, and it will send it to your monitoring tools. It will not send data back into your network, so you can't really send data back into the network. Now, sometimes some admins will use span ports. However, the problem with span ports is that it's essentially a mirror port, and the challenge is you really don't want to use that because it only really works when you have your bandwidth requirements are low. As soon as the bandwidth goes up, well, what happens is that the switch cannot handle it, it's best effort, and will start dropping packets on your span ports. Well, you need more visibility when data traffic goes up, because that's when problems happen, and that's when you don't want to lose information, again, because the goal is to eliminate blind spots. So we highly recommend taps. These are passive devices. It's a bump in the wire. Very simple. There's also the concept of a bypass switch. In a bypass switch, you can bring all your tools and monitoring fabric inside the network inline, so it can be on the critical path. The bypass switch is very simple. It will be transparent to the sender and receiver in a network, but what it really does is that it will divert that data and send it to your visibility fabric. It will send it to all your monitoring tools, intrusion prevention, intrusion detection tools, and then send it back. Now, if any of these tools that are now inline and are on the critical path fail, the bypass switch will automatically detect that, and then you can take action automatically. Maybe you only want to bypass that particular tool. Great, it can automatically reroute that traffic. On the other hand, if one of the tools that failed is an intrusion prevention tool, well, maybe you don't want any data to enter your network or exit your network without being inspected, so you can essentially disrupt the traffic to your network. So it's very programmable. So we recommend using taps and bypass switches. Now, given that there's virtualization, we also have taps for virtualized environments, KVM, VMware, Hyper-V, OpenStack, and of course there's the cloud, and we'll talk about that separately. Now, once we aggregate all this data or access all this data, we want to be able to send it to our tools, but this is where we start using the concept of a network packet broker. A network packet broker can look like a switch, but it's not a switch. A switch, when you insert into a network, it has to follow certain protocols. It has to essentially discover its neighbors and start forwarding traffic based on certain rules. A network packet broker, on the other hand, even though physically it might look like one, it allows you to do packet level processing and send the package to anywhere you want. And this is very important, and I'll give you the examples here. What we're showing on the screen is called out-of-band monitoring. On the left, we have connected taps, physical taps, or it can be also virtual taps running on our server, and we're accessing all that data. Remember, now we have tapped every single link, and we have a lot of data, so we can't really just send it to our tools. It will just be too much data. So we're going to groom it, and then using our packet brokers and send it to our tools. Here we can aggregate the data and we can filter it. Maybe I only want to send data on certain VLANs to certain tools. So I can filter it based on VLAN, MAC address, IP address, and so on. I can even filter it based on application. Some advanced packet brokers can automatically detect which applications are running in your network. In fact, in the graphical user interface, you can see the application. You can say any data, somebody's streaming, somebody in Brazil using an iPhone 7 is streaming Netflix traffic. I don't want that to be inspected, or maybe I do want that to be inspected. So I can just, using a simple drag and drop, send that data to one of my tools, and so on. For example, I might want to be able to do deduplication. If you look at the picture on the left, I'm tapping every single link. It's possible that as packets are moving from one switch to another, I'm tapping the same packet over and over again. This means that, I'm going to exaggerate, but there can be 10 multiple identical copies of the data that is now going to go to my tools. Well, that's just a waste of bandwidth. Instead, maybe I can use a packet broker to do deduplication and just send a unique one. I can reduce the traffic by 90%. That's a 90% savings on your tools. That's immense. I can do other things. Maybe I'll just filter it based on other criteria, as I mentioned. Maybe VLAN, maybe MAC address, maybe IP address. I can, again, based on filtering, maybe I'll say, I want all my Facebook traffic to go to a particular tool, all my Skype, Twitter, LinkedIn traffic to go to other tools. The ability to automatically identify applications is very powerful. And when you combine it with a graphical user interface, it becomes very easy to operate. And if something is easy to operate, you get more out of it. As you can imagine now that you're becoming familiar with network packet brokers, you realize that these are not regular switches, and regular switches cannot deliver the features of packet brokers. I can maybe filter based on geolocation. Maybe I only want to send data that is coming from Germany to a particular tool because for whatever reason. If I'm running a network, a business network, and I don't expect any visitors coming from Korea, I might check that as a threat, and I might want to have a look at a close inspection. And I can send that traffic just based on the geolocation information. Again, this is very, very powerful. I might want to do data masking. This is very common with banks and hospitals where they have privacy laws and very strict laws. So before you send that data to your tools, you have to mask certain bits and bytes. Again, I might want to reduce headers. I might want to remove MPLS labels or I might want to trim them, strip them. Again, these are all things that allow me to send less data to the tools so that the tools can do their jobs better, or I don't have to overinvest in the tool, essentially helping with rolling out a monitoring infrastructure in a cost-efficient manner, and so on. The last thing I want to highlight is, of course, the fact that you would want to need a very good user interface, and we're going to spend more time on it. The reason why user interface is so important is that a lot of customers typically use this as a set it and forget it method, meaning that they'll set these rules up and won't use it, won't look at it for months. Now imagine if you're a network admin and at 3 a.m. in the morning you get a call and they say, well, something's not working, you need to come and have a look at it. If you haven't touched this tool for 4 months, what do you want to do? At 3 a.m. in the morning, do you want to go over some obscure CLI commands and try to remember how you program this, or you want to be able to use look at a graphical user interface which in minutes tells you how you enter the rules and help so that you can focus on troubleshooting rather than trying to figure out how you use the tool. So it's again, very, very powerful. So everything that I just talked about was out of band. We were copying data from the network and sending it to the tools. No data was going back. But there's also the concept of a bypass or inline. If I want to bring all these tools inline, so rather than just looking and saying, well, I think an intrusion might be happening, maybe I want to prevent an intrusion from happening, I can bring these tools inline, and this is where a bypass switch comes into play. Again, I still have my fabric of network packet brokers, but now the combination of the bypass switches and the packet brokers can detect anomalies in the network. And if any of my tools fail, I can take action as to whether to bypass that network, bypass that tool, or just block traffic altogether. Now, one important thing is that we typically use bypass switches that are disaggregated, meaning that they're not integrated into any other device, including the network packet broker. And this is very important because that bypass switch is at a very critical point. It has to have a very high mean time between failure because it's in line and it's guarding your monitoring fabric. So everything might fail, that bypass switch should not fail. And the way that we do it, we achieve that high mean time between failure is that by designing a very simple device, not making it complicated. If you integrate it with your packet broker, you might be able to reduce costs, but the consequences will be that now you have a fairly complex device that might fail, and you don't want the guard who's guarding the other tools to fail. Simple as that. So we recommend using a disaggregated approach. And if we combine it together, now you have out-of-band monitoring and inline. And really, these are the two basics, the fundamentals of essentially have monitoring is out-of-band and inline. As I mentioned, our goal is to access data everywhere, then apply some filtering concepts, apply some context-aware data processing, such as packet trimming, deduplication, SSL decryption, and finally apply a last piece of intelligence where you can automatically detect applications, automatically detect where that data is coming from, geolocation, and you can use it for both simplifying your filtering, or you can use it as a threat intelligence. I was with a bank once, and they said that they have allowed certain devices and certain applications in their network, and they have banned everything else. And by looking at this tool, this network packet broker with application intelligence, they were able to see all the data going through their network and identify if there was a device that was banned or an application that was not allowed that might be running in their network. So this is, again, very powerful. Now you can imagine you have all these taps, bypass switches, and now fabric of network packet brokers. You don't really want to manage them hop by hop, and this is where a single pane of glass comes into play. You can manage all of these through a single interface, and that interface is shown here. Here we have this column called network ports. Those are ports that are connected to your taps for out-of-band monitoring. We have these tool ports. Those are ports that are connected to your tools. And in the middle, I can apply filters. I can apply any filter that I want. It's a very simple drag and drop. For example, here, I have aggregated ports 1 and 2, and I'm sending out on the tool ports. Essentially, I'm aggregating data, but clearly I cannot just take two 10-gig ports and send all that data to one 10-gig port. Data would essentially, there's a mismatch of data or bandwidth. But now, by applying filtering or by applying advanced methods such as deduplication, packet trimming, I can indeed send that data without dropping any packets. And this is very important. Here I have the same user interface, but now it's inline because, as you can see, I have a bypass switch. I'm showing my network and tool ports, and I'm even showing my tool vendors. In this particular case, it's a Cisco Firepower. Again, very powerful, very intuitive user interface. Here is, again, same platform showing application level intelligence, showing all the apps that are running in my network. I can see where the data is originated. I can, from a long list of applications, I can see all the applications that are available. We have a subscription plan. It means that every 2 weeks, an update is pushed down to your network packet broker because there are new applications coming up. Application signatures are changing all the time. I remember when I think there was a game called Pokemon Go, and then in 2 weeks' time, it showed up in our application list, and you can see if somebody was streaming data related to that platform. Again, very, very powerful. We have a long list of thousands of applications. Again, you can use it to filter data, or you can use it for threat intelligence. Why is this application running in my network? Why is somebody from this country using this device in my network? If they're not allowed, I can send it for closer inspection. Again, these are all very, very powerful. And we also, of course, can generate net flow and a summary of the data, essentially metadata, there are a lot of tools that will essentially digest that net flow and use it, so we can deliver high performance net flow too. And here it is how it comes together, whether it's your taps, your bypass switches, and your network packet brokers called the vision devices. They all come together under a single pane of glass. Now, what we haven't addressed or covered is what do we do with virtualization, whether it's on-prem or applications on the cloud. And there we, again, using a single pane of glass, we have our Cloud Lens solution that I would like to spend a bit of time on. We know that there is this tremendous move to the cloud. It's not stopping, but guess what? Security in the cloud is a shared responsibility. In fact, there's a document from Amazon that says security in the cloud is a shared responsibility. So you can't really just expect whether it's Amazon or any other cloud service provider to completely address all your security needs. Therefore, there's something that individual customers or users need to do. Again, you still need to be able to access data. What we're seeing is that a lot of customers who are migrating to the cloud, either they want to use their same tools on-prem, so they want to send the data from the cloud to on-prem, or they might be also migrating their tools to the cloud too, but they still need to have access to packet data. But guess what? You can't really, Amazon doesn't have a service for packet data. So there's no easy way to access it. What you used to have on-prem is not easily available in the cloud. So you need a solution there. You need something that is elastic. Your applications are elastic, especially with Lambda and serverless computing. You can even get computers or servers for within minutes, and your applications scale all the time. So you need something that will scale with them. Of course, has to be able to handle complexity, has to be cost effective, and of course have to provide security and highly available. So to do that, we have developed and delivered Cloud Lens, and it works both on-prem as well as off-prem. So if you have a VMware, an OpenStack environment on-prem, or if you're running applications in the cloud, it will work. It doesn't really matter. It really has two requirements, or it consists of two components, really. One is that it's a SaaS platform. Simple as that. A lot of enterprises are using SaaS, Salesforce, Workday, so many applications, and this is no different. It's a SaaS platform. Its backend is in the cloud. And second, it uses Docker containers. It's a container-based solution. And so what will happen is that whether this is in the cloud or on-prem, these Docker containers will attach themselves and monitor your applications. Here is a good example. We have the Cloud Lens SaaS backend up here. We might have some applications running. It doesn't really matter which cloud service provider it is or even on-prem, and you have your tools. So you have your applications running. They're generating some traffic, production network traffic, doesn't really matter, and you want to deploy Cloud Lens. Well, the Cloud Lens agent will associate itself with your applications as well as your tools. And the agents will dial back to the SaaS platform to provide some data. For example, what is my IP address? Where am I? Which cloud service provider am I at? Some applications might be running on Google, some on Azure, some on Amazon, and some on a VMware on your private data center. They have to be able to tell exactly where they are, as well as we have to know where your tools are. But once that is complete, essentially, it will start sending data from your production network to your tools. Again, this is a many-to-many mapping. You can send data to one tool, multiple tools. It doesn't really matter. The only requirements is that it's a SaaS platform and it's a Docker-based container platform. It's as simple as that. And as your applications scale, the monitoring solution will scale too. So you do not have to worry about anything at all. And there is no single point of failure in this platform. This is, I would say, a very different approach taken compared with some of the alternatives out there. For example, this is completely cloud native. We use a lot of the services provided by cloud. It's very elastic, auto healing, all of the cloud native technologies. So it's not a lift and shift. It's designed from the ground up. We support usage-based, meaning that you can just sign up and you might just be monitoring one application with very low bandwidth. Doesn't really matter. Just pay as you go. And if you're in 2 months, you scale up to 10,000 instances, then you won't have to pay for that. So it's a very cloud-native solution with a cloud-native business model, should I say. And so this is essentially our cloud lens solution. Again, all of this through a single pane of glass. So hopefully this background was very useful for you in terms of understanding the fundamentals of providing visibility and security, both for your traditional networks, and I focused on the more of an enterprise data center, but it doesn't really matter whether you have a branch, distributed branches, WAN, or applying it to some of the new technologies such as CORD, central office, re-architected as a data center. If you're if you're part of the service provider market, it really doesn't matter. We have customers in all of these segments, so it's applicable to all of these. So hopefully that gave you a bit of background on both visibility for your traditional networks using hardware-based appliances, as well as some of the cutting-edge technologies that we're using for visualized environments, as well as the cloud. So this really concludes the slides that I was planning to present. I believe we have a few minutes for Q&A. I don't know if there are any questions. Yeah.
There are some questions for you. Yeah, let's talk about Q&A now. So let's see, the first question that came in is from Dan. Dan is asking, does the Ixia solution slow down network access? Meaning, does it provide latency as it scans to provide these visibility features?
Sure. So for out-of-band, it doesn't, in the sense that, well, for out-of-band, it doesn't really affect your production network, because out-of-band means that you were really copying all that data, and so everything is happening in parallel without affecting your production network. Now, when it comes to inline, and I can try to go back to the inline picture here. For inline, it indeed does introduce latency, because communication, if we look at inbound communication going from A to B, it will have to go through bypass switches, your network packet brokers, and then all the other tools. Now, you can serially connect these tools or connect them in parallel, but nevertheless, it will introduce latency. Now, the latency is typically very low compared to all the other devices in your production network. And typically, we don't really see a big issue on your on typically the enterprise data centers. We see more of a hesitation with service providers, especially as they're providing services to their end customers. They want to minimize latency. There are ways to minimize latency. For example, you do not need to connect all these tools in series. You can connect them in parallel, so any data can be distributed in parallel and then aggregated in parallel. So there's ways to mitigate latency, but indeed, when it's inline, there's a latency hit. But this really requires further investigation depending on what your tolerance level is. Now, on the cloud side, here, what I was showing with Cloud Lens, again, this is in a way out-of-band monitoring. So here, it doesn't really affect your production network, so it won't affect latency at all. But very good question. Thank you.
Yeah. So there's a couple different ways you can monitor in-band, out-of-bound. Another question that came in here is from Alan. Alan's asking, what services or applications do you offer or provide for continuous filter tuning?
For continuous, oh, great. Okay. So to reduce on the number of slides, I didn't really go into the details here, but that's a great question. This example, I'm just going to pick the out-of-band example. What I've not shown here is that everything that we do for filtering, whether it's using a CLI command or a graphical user interface, is available through REST-based APIs. And this means that if I want to automatically change my filtering or continuously adapt and change my filtering, I can do so by calling the RESTful API. So we have two systems that we enact and deliver for our customers. One is that there are a number of tool vendors that we have worked with where they can call our APIs automatically. So if we're sending data and there's a filter rule that sends some data to some tool, and that tool says, well, I think there's an anomaly here. I would like to have a closer inspection. I want to change the rules so I get more data, or maybe I don't want to do the packet trimming. The tools can directly call the network packet broker, the RESTful APIs, and they can automatically in real time or close to the real time change the filter rules. So this is typically very, very common, and it's very easy to do. Again, everything that you can change in the packet broker is exposed through RESTful APIs. The other thing, again, because of time constraint, I didn't go into is our Cisco ACI integration, and this is really more for Cisco environments, but we expose our interface, again, same RESTful APIs, to the API controller, and then we have a program where if the API controller is making any changes in the network, it might be changing VLANs, it might be bringing up new applications, it will automatically call our packet brokers and propagate that change immediately. So if something's changing in your network, it can automatically change the filter rules, and this would get the continuous filter regulation that you were asking for. So really two methods. One is more specific to Cisco with the Cisco ACI and API controller, and the other one is where the tools can directly change the filters themselves. But a very good question. Thank you.
Sure. Another question here is about kind of the scale of CloudLens. Like, where does it start? I mean, could you start if, say, you just had an application in the cloud? Can it just be a CloudLens, a view into just that single cloud-based, cloud-native application?
Yes.
I mean, does it need physical hardware?
Oh no, it does not need physical hardware at all. So I'm pushing the, I'm showing this image again. And in this particular case, you might just have one application in the cloud, and that's all we need. We don't need anything else. There's no hardware needed. Everything is in the cloud, and you can just essentially connect it to that application and send traffic wherever you want. Everything is in the cloud. Nothing has to go to a hardware platform. Now, we do get, by the way, this is a good question. We do get the reverse of it, where the customers say, well, I have applications in the cloud, but I've done a significant investment to buy my hardware-based tools that are on-prem. Can CloudLens bridge the gap? And the answer is yes. So we can, even if you have a single application in the cloud, we can just get that data, and you can, of course, filter. You don't have to send all that data. Maybe you just want to send certain amounts of data, and we can just filter it at the source and send it to your on-prem hardware devices too. So it goes either way.
Excellent. And is there how do people typically get started with CloudLens? Is there a trial? Is there a demo? Or how does that work?
Oh, great. Yes. So you can you can provision it by yourself. It's self-serve. If you go to the ixia.com website and click on cloud, there's a trial. There's a trial for 4 to 5 days, and after that you will be billed, or you'll just have to terminate your service. But absolutely, it's a self-serve visibility service. So just go to the website, click on a couple of things, enter your information, and that's pretty much it.
Excellent. Well, I think that's all the time we have for questions. But Rajiv, thanks so much for being on and talking to us about visibility as a service today.
Thank you very much for your time. Great questions. I really appreciate it. Thank you.